This is Dr. Rebecca Johansson, running and triathlon coach with the Performance Project. You can find us at theperformance-project.com. Today's sports science mini lecture is continuing on the theme from last week, detraining and endurance athletes. Last week we discussed cardiovascular variables and how they change with detraining, and this week we're going to be discussing mitochondrial content. So the first question to answer is, what are mitochondria? So mitochondria are the nickname that they have is the powerhouses of cells. So the strict scientific definition of the mitochondria are subcellular organelles responsible for the production of ATP with oxygen, and it contains the enzymes for the Krebs cycle, electron transport chain, and the fatty acid cycle. Okay, so that's a very scientific, wonky definition, but we're going to discuss this in practical terms. So basically, what the mitochondria are able to do is we consume carbohydrate, fat, or protein, and that ultimately gets converted into energy that the cells can use. So the cells can't use carbs, fat, or protein for energy. It needs to go through a series of steps in order to be converted to usable energy. So the mitochondria help with that conversion. So in the presence of oxygen, carbohydrate, fat, and protein get converted into ATP. And ATP is energy that cells can use. And all cells need ATP to stay alive. Without ATP, the cells die very quickly. All right, so in this picture, what we see is the steps that we were talking about. So in the top, we see protein breakdown, glycolysis, which is going to be the conversion of carbohydrate into energy that the cells can use, and then breakdown of triglycerides, so breakdown of fats. So once we get into the blue region, then you're inside of the mitochondria. And what happens inside of the mitochondria is the Krebs cycle and the electron transport chain. So the point of the Krebs cycle is to produce reduced electron carriers, and then those electron carriers get shuttled to the electron transport chain, and the electron transport chain produces ATP. Okay, so we're going to go back to the basics again. So the mitochondria are able to take carbohydrate, fat, and protein, which is food that you ingest, and in combination with oxygen, it gets converted to ATP, which is a usable form of energy that's required by all cells. So mitochondria, powerhouses of the cells, produce a lot of ATP, which we need to exercise and which we need to stay alive. In reference to detraining, on this graph on the x-axis we have weeks of training or detraining, and on the y-axis we have muscle fiber mitochondrial content. So in week 0, we're going to, in this hypothetical situation, we have an individual who's untrained. So maybe their muscle fiber mitochondrial content is at 5, and these are just arbitrary units. Then that individual starts to train for maybe a 5K or 10K, so they've started some aerobic endurance training. After 5 weeks of training, now they've doubled the mitochondrial content of their skeletal muscles. Okay, so great stuff happening for this individual. Then that individual maybe gets sick and they have to be in bed for a week, or a work deadline comes up and they aren't able to do any training whatsoever. Well, from week 5 to week 6, so only 1 week, they lose approximately 50% of what they gained with 5 weeks of training. So it happens quite quickly. And then let's say after 1 week of missing all the training, that individual starts to train again. Well, it takes from week 6 to week 10 to get back to where the individual was before they took the 1 week break from training. So it's a bit depressing, but what's important to keep in mind is that you don't have to do very much exercise to maintain the physiological adaptations that you got from weeks of training. So this is where high intensity interval training comes in, and if your training volume has to reduce a lot, doing some short high intensity sessions can make sure that your adaptations can stay at full capacity or nearly full capacity. And that's going to be next week's mini lecture is going to be on the science behind high intensity interval training. And this is particularly applicable to the coronavirus pandemic, and with most of us being under some sort of stay at home order. So we'll look forward to that one.